Okay, let's start with Yilmaz then.
Hello and welcome to the AI Code Camp session again. Today I'm going to talk about understanding AI neurons and activation functions with C++ Builder. This is Yilmaz Yoru. I'm a mechanical engineer, C++ developer, also Embarcadero MVP, and I have a company and doing projects mostly about software and AI applications. In this presentation, I'm going to talk about how AI works and what is activation function, why it is necessary, and what kind of activation function types that we can use in programming with the C++ examples. Actually, these examples are in general C++ examples, so it is not based on the C++ builder, so you can use in other C++ compilers. I'm a mechanical engineer. I have a company, essential company. We are developing engineering applications, 3D designs, programming, and we are also developing AI applications and also developing an artificial general intelligence application. Actually, my programming history began before the mechanical engineering. Since in 1988, when I was in secondary school, I think I started to write code. I have more than 500 blog posts at Learn C++ or Embarcadero.com blogs, and we are developing many different projects. One of the biggest projects is Abriana project, artificial general intelligence project. Also teaching innovations to kids, students, and young people sometimes. And these are some of our software projects that we develop in C++ Builder. Now let's start with some introduction. AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also apply to any machine that exhibits traits associated with a human mind, such as learning and problem solving. And in general, there are two kind of fields in artificial intelligence: machine learning and deep learning. Machine learning uses algorithms to learn from data, finds patterns in data, and make predictions about future events or outcomes. In the deep learning, it is a neural network with layers and filters, attempts to simulate the behavior of human brain, allowing it to learn from large amounts of data. So in machine learning, there are less layers, less data. In deep learning, there are more layers and filters and operations and more data. ANN, unsupervised learning, supervised learning, and reinforcement learning are machine learning examples that we can say. And some of the deep learning examples are natural language programming, convolutional neural network, recurrent neural network, generative adversarial neural network, deep reinforcement learning, generative pre-training, which is much more popular nowadays. This is the schematic of AI in general. At the center you can see artificial general intelligence, which is the core of the AI that we call, and there are other machine learning and deep learning AI technologies. Now let's look at how AI works. In the mid-18th century, Luigi Galvani did seminal experiments on how electricity signals activated muscles in the body, and he used the frog legs here, making the legs of the dead frog twitch after zapping them with electrodes, and was among the first scientists to discover bioelectricity. And then scientists researched the action potential in biological neurons. So there is a threshold to give when there is a signal, there is a threshold, and then there is an action potential coming and resting state. Artificial intelligence is based on artificial neuron theory, and there is a artificial neuron model, very basic, and it has many inputs from coming, and each input has weights which has on their links, and we sum all of these inputs to the artificial neuron, and then at the end we use artificial function to define output if it is necessary we give output. If not, we don't give output, something like this. So a minimum artificial neuron has activation value, activation function, and weights, input net link. So it has one activation value, one activation function, and one or more weights, depends on the number of input nets. The activation function, also called as a transfer function or threshold function sometimes, that determines the activation value from a given value from the net input function. Here the net input function is the sum of the signals in their weights, and activation function is a new value of this sum with the given function or conditions. In other words, the activation function is a way to transfer the sum of all weighted signals to a new activation value of the signal. There are different types of activation functions. So now we can connect each of these artificial neurons to other neurons together. Then we can obtain artificial neural network. This is a very simple artificial neural network example that has 4 inputs, 1 output, and there is a 1 hidden layer. At the end, you can compare your results with other results by using mean square error or root mean square error formulas, or also you can use normalized mean square error functions. When you are training this network, this time we use backpropagation algorithms, which is coming from output to the input, and we use derivative of these activation functions. So it is very important to how and which activation function you use when you need a derivative function, because this depends on your speed of computation, or it may depend on your results or training stability. So it is very important to decide your activation functions when you have an artificial neural network problem. This is a very simple artificial neural network example with 2 neuron inputs, 1 neuron output, and each neuron connected to the output neuron with the link, and link has a weight, which means which input is much more important, which input is less important. We define this by weights, and then we multiply these weights with the input values. For example, we multiply input value 0 with the weight 0 and input value 1 with the weight 1, and then we sum all of these values together, which is called as net input value. Then this sum needs to be used in an activation function. So we need an activation function here to define if we gonna give output, what kind of output we will give from this sum of results. Okay. As a result, as you see, AI works with neurons, inputs and outputs, and there are weights that we multiply with input neurons values, and we have an output, and so we have many neurons, inputs and outputs, and so we have many multiplication together. So if someone asks you what is AI, if he is not from the engineering or AI field, I find a very simple definition here. AI is a kind of multiplication table. So there is a multiplication table for a cat, there's a multiplication table for a dog, something like that. We can explain this very easily. AI is a set of computational techniques actually that allows you to solve various problems. In today's AI technology, we have machine learning and deep learning technologies, and we are using activation functions a lot. So it is very important to decide your activation function very well and very fast in algorithms. This affects your computational speed and affects your results and affects the performance of your AI application. Now let's look at some of these activation functions in artificial intelligence. First, identity function. An identity function, also called an identity relation or identity map, or sometimes it's called as identity transformation function. It's a function in mathematics that always returns the same value that was used as its argument. That means your net input value has no effect to activation function, directly returns the same value. It is a y equal to x function, or fx is equal to x function. This function can be also used as an activation function in some AI applications. So here is a very simple function example here, but if you define to use identity function, you don't need to use it, just use directly in your net input function. So this is a very simple activation function example actually, and it returns a floating number and gets floating number. Values generally between 1 and 0, or -1 to +1. And also this function is very important when you are training, because when you are training you need derivative of these activation functions. So it is very important to do better computation and faster computation in when you are training your artificial intelligence. And the next function is binary step function. Binary step function or Heaviside step function, or it's also called as unit step function, is a step function named after Oliver Heaviside, the value of which is 0 for negative arguments and 1 for positive arguments. That means it results 0 or 1 as a boolean. This function is an example of the general class of step functions, all of which can be represented as linear combinations of translations of this one. So it's a bool function. It has a floating input, sum of net input value, and then as a result we give 1 or 0, it depends on this summary. And here is a simple example of this in C++. Now third one is logistic function. Logistic function or logistic curve is the most common S-shaped curve. Also we are using mostly sigmoid function in this category with the equation as below. And here is a very simple example of logistic function here. And one of the most popular logistic function is sigmoid function. So it is a standard logistic function where L and K is 1 and the x0 is 0. So we can write the sigmoid function as below, or we can use hyperbolic tangent as below in C++ examples. Fourth one is a hyperbolic tangent function. It's a trigonometric function that we use hyperbolic tangent as below. So here is an example of activation function here. So we can say it is maybe much more smoother than the logistic function. Fifth one is exponential linear unit function. It is an activation function developed by authors and that speeds up learning in deep neural networks and leads to higher classification accuracy. So when the net input value sum is lower than the 0, so it has less effect as an output here, and when it is over the 0 value, then it has much more effect, as you see in this graph. And here is a simple C++ example as below. Sixth one is scaled exponential linear unit, SELU. It's another activation function released with the self-normalizing neural networks paper in 2017. They introduced self-normalizing neural networks to enable high-level abstract representations here. It's a kind of scaled version of ELU activation function, we can say. So just multiply ELU value with the lambda, that means CELU. So it gives you scalability in your activation function. Here is the formula and graph of the CELU function and a very simple C++ example of the activation function. And the other one is rectified linear unit function. It's a ReLU activation function defined as the positive part of its argument. Can be written as fx is equal to max 0 and x, where x is sum of weighted input signals, which means it's a net input value in an artificial neuron. And ReLU function, also known as a ramp function in engineering. And also there is a parametric ReLU function with the beta, and here is a very simple C++ example below for the ReLU function. And the other one is Gaussian error linear unit function. It's an alternative to ReLU and ELU functions defined and published in 2016. It is used to smooth ReLU and ELU activations. So GELU function can be written as below here, as you see in formulations. And if you look at the graphics, as you see, when the x value is lower than the 0, it is very less effective, and if it is much more below the 0, then it has no effect here. And if it is positive, then it has much more effect as an output. So here is a very simple C++ example below here. And the other one is soft plus activation function. It is developed in 2001, and it is the replace of sigmoid of a sum by a product of soft plus or sigmoid functions over each of the dimensions. And here is an example to the soft plus function in C++ as below here. So there is an exponential function and logarithmic function used as a return. And the other one is self-regularized non-monotonic activation function. It is also called as MISH function. And in this function, it is very smooth and continuous and self-regularized, and it is also non-monotonic activation function. This function is published in 2019, so it's a very new developed function. As you see, it is very effective in calculations and training, and derivatives of MISH and SWISH functions also compared here in the first and second order. And MISH activation function can be defined by using soft plus, as we explained before. So it's a hyperbolic tangent value of the soft plus function. So we can write MISH activation function as below here. So it has ln function, exponential function, and tangent hyperbolic functions as a return. And that means it is a little heavy in computation, but might be very useful in some of your applications. And another function is softmax function. Actually, it is not an activation function, I think, but I want to explain because it is very useful and it's very used in deep learning and GPT applications. So softmax function is used to soft outputs between the 0 and 1. It can be used as an activation function too. The softmax function is often used in final layer of the neural network based classifier. These kinds of networks are generally trained under log loss or cross entropy methods that are a non-linear variant of multinomial logistic regressions. So you are using ANN or other neural computations, and then you do some filters, and at the end you are using softmax to normalize all these results between the 0 and 1. So for a X vector or array which has n members in a softmax for each member can be written as below. This function may overflow due to infinity results. To avoid this, you can modulate x value by subtracting a maximum value m. So this can be used as here. And here is an example to the softmax function in C++. This is explained in learnc++.org well with the full example. So you can use it in free and easily. And of course, there are other activation functions in artificial intelligence, and you can create your own activation function, of course. But be sure that your activation function has a derivative function for training your network. And also avoid to use much more computations, and avoid to use if clauses as much as possible. And then your activation function may operate in high speed in millions of neurons of your application. You can check all of these examples and full of C++ examples in learnc++.org, and also you can check other activation functions in Wikipedia. Thank you very much for listening me, and I hope you enjoyed this presentation. At the end of, I use this wallpaper, which is a screenshot of Abriana zoomed in the neural network activation. I hope you enjoy, and thank you again.
I think I made myself come on screen, just, appear on screen just a little bit too quickly there. The good news is Yilmaz is here in the studio to join me live. Hello, Yilmaz. How are you?
Hello, Ian. How are you? Nice
I'm
to
good.
see you.
Yeah, we don't often see each other. We've known each other for years. You used to write, and you still do write, a lot of C++ articles, and I've edited, I don't know, you've written thousands, so I don't know how many I've edited, but it's a lot.
I know. Especially on Sundays, I was working.
Yeah, same as me. We did a lot. And I've just, for those that want to know where it is, that's, if they scan that code, it will go straight to it as well. And I'm going to put your site up. I'm really glad that you joined us. Funny thing is, although I joke around about, I don't understand the questions that people ask, and then when you give an answer, I don't understand the answer. That video actually made sense to me. I actually understood it for the first time. I'm like, oh, I get it now, with the curves and all the rest of it. And on your, because you've been doing AI since the 90s, is that right? It's a long time you've been doing.
Before the 20, yeah.
Yeah. So it's a long time, and I mean, really, the funny thing is that now everybody is coming along and saying, "Oh, they understand AI." There's lots and lots of AI experts and stuff like that. But you are a guy who's been doing it for a long time, and I really respect you for it. And I remember, when you used to produce, because I see people are scanning the code, but when you used to write these articles for Learn C++, there is a lot of AI stuff there, a lot of things about ANN, neural networks, and things like that. So if people want to learn the math behind what goes on and actually understand genuinely how neural networks work, and what the real differences are between general artificial intelligence and very specific artificial intelligence. In fact, how would you describe that, the difference between general artificial intelligence and what we're seeing at the moment, that people are claiming is artificial intelligence?
Actually, we are about to get close to the artificial general intelligence. ChatGPT is really have nice course today, and other GPT AI technologies. But let me explain something with an example. As you know, we born as a baby. We have nothing in our brain, and but our brain is growing up in 9 months. Maybe I don't know. This is a health maybe area. I don't know, but a medical area. Uh, he- he's sensing something and then getting growing slower. Maybe it is getting some information from output, and then at the end, it is in environment. Now it is getting inputs from the environment, from his mom, dad, etc.
And it
And then
senses, touch and smell, and yeah.
touching, sensing, hearing. So neurons are changing their ways, their weight values, maybe their activation parameters are changing. So it is learning, you know,
Mm.
by itself without doing anything. So at the end, you have a very teenage son or daughter, you know. So
Mm.
it's able to do everything: running, talking, discussing. Sometimes it's making compliments or creative things. It's creating new songs or pictures,
Mhm.
art, any other things. So this is the what we have as a human. So in artificial general intelligence, you have a core something like this as a baby brain, you think. So you give just inputs, okay? At the end, you see it is doing same things or better things, faster things. So this is artificial general intelligence, I think, if we achieve this.
Yeah.
So if it is successful, of course, computation is very fast in computers than ours, and so there will be much more higher intelligence things that can be in the artificial general intelligence. So all is about maybe this AI is also signal processing actually.
Mm.
So the one neuron producing a signal, then another neuron decides to receive this signal or not, or the previous neuron decides to send this signal or not. This is a signal processing actually between the
Right.
neurons. So this is why I want to explain. Actually, activation functions are very simple mathematical functions, but I want to give some motivation to developers. Maybe they find something better activation function, or maybe not. Actually, still I like the sigmoid function. It's very useful because both negative and positive sides affecting to the results is same. Um, actually, activation function means something like how much, if it is positive, how much should I record this data? If it is negative, how much negative should I care about it? If it is much more negative, should I care about it, or is it zero? So all you see the graphs on the y-axis is the result. So it is about to arrange these kind of things, and sometimes they use some extra parameters to see changes between those different settings, different setups. So they are scaling or changing their parameters. So all is about to modify the input and output correlation or something like this.
Yeah. And I think what's interesting as well is I noted this down. You said there was a MISH function, and that it
Yeah,
was only published in 2019,
yeah,
which
that,
is only 6 years ago. And this is the thing, that this technology, it's the math has been around for a long time, like 1920. Some of those equations were published, but it's still very much a area where there is still much to discover, and much new stuff is appearing all the time. And OpenAI has only been around for 3 years, I think.
yeah.
And obviously now everybody wants to do it because lots of money is involved in it. But in 2019, that's quite incredible. There is a question from Callum Duffield. I'm not sure whether you know the answer to this, but he says, when considering activation functions for a neural network, what are the main things to consider? For example, are some better at handling exploding or diminishing values? I'm not sure what the answer would be to that. That's why I'm going to leave it to an expert.
Yeah, actually, activation function is a function between two neurons. We are not talking about many neurons, artificial neural network, or many complex neural structures. So it is between the two neurons, two values. So if you know two values, two input and output, this neuron and this neuron, your neuron structure, I don't know your neuron structure. What is the meaning of this? Maybe you are trying to analyze a picture, maybe trying to analyze your a sentence, or maybe you try to analyze the coordination system as I did, So you know the numbers, input and output of these neurons, and you want to give the necessary or importance, how much important if it is positive, how much important if it is negative. Maybe much when it is much more negative, it should be very dangerous for you, so very negative, much more negative. Maybe you should change your activation. So it is about handling those values between, which is much more needed for you. I think sigmoid function is very successful here for me, but you can you can test different activation functions. So you just change the function name, you can also change you can do in case state. So you can change your activation function, and also you see there are some parametric activation functions. So you can add those parametric activation functions. So you compare results, which one is better for you, which one is not good, or maybe you can compete with each other technologies. AI is little bit about tuning values and parameters. So in real, actually, we don't know which parameters are using in ChatGPT, So because they are testing something, they see something is not good, it is caring much about some dangerous thing, then they are reducing its values or changing some parameters. So it's about it. If you know your problem, if you know your values, so you can decide your activation function.
Yeah. I mean, really what we're talking about here is what is happening in some of these artificial intelligence networks. And let me just block that person who's trying to spam us, silly person. As far as you understand it, and I know you can't answer completely accurately because you don't work for them, but is this kind of thing what is happening behind the scenes on things like ChatGPT and other types of large language model? Are they actually really just doing exactly what you're describing, but on a massive scale? Do you think that's what's happening?
Yes, of course. This is the main idea. Actually, of course, it is much more complex. I give the ChatGPT structure example in the first presentation. They are using different layer operations, again filtering, and again doing some operations, again using softmax, again looping. Maybe they are using some if clauses, maybe some other logics, maybe other AIs, or also checking, I don't know. So it's very complex in general, but these ANN and artificial activation functions may give you some idea. Generally most of programmers today know Python well, so they look at watching videos and look at things. So giving parameters and functions, and then calculate the results. So they don't know what's happening behind this. So this is why I am explaining here very basically, very core things here. Actually, I am working on the field alongside. This is my not primary area, but one of my focused areas here. But there were much more academic stuff were working here. There were many different studies in academic. If you check papers, you can see. So
Mhm.
people were working, but when the ChatGPT was successful and the results was very important, maybe you remember Cortana was very promoting thing when it comes with the
Yeah,
Microsoft Windows.
Cortana, it was not good.
Yeah, and I said, "Whoa, they made it something like this." But when you use, you see results not useful, you know. So
Mm.
you feel not good, then they reduce it. Now it is a chat, but in the chat GPT, it was very different because
Yeah,
results was very good, very promising, and sometimes uh, you blow your mind. You know, when it answers you, you blow your mind. So it's
for
very
sure.
important, I think, in this
Yeah.
technology. Yeah,
For me, I because I think about I like Amazon Alexa. I think it's pretty useful, and Cortana. Yeah, I mean that was a bad idea from day one. But Siri is still good today. But all of those work very differently from ChatGPT, and I think behind the scenes, essentially, they're just a big set of if statements. If the person asks this, then it gets the context from what they're asking, the natural language, but it really is just trying to understand the question in natural language and then make a query out of things it knows. Whereas ChatGPT is much more than that. It is a more, yeah, I mean, it tokenizes the knowledge, but it's not really like a database. It's a little bit more alive than that. Whereas my opinion, and I don't know because obviously I didn't work for Amazon, but in my opinion, Alexa and Siri were much more just very clever search engines with lots of built-in functionality. ChatGPT, I think, really took Microsoft and Google by surprise. I think Google, in particular, were very troubled by it because
yeah,
all of a sudden it threatened their business model because the Google searches were very clever. PageRank was the algorithm that was used, invented by Larry Page from Google and patented, I believe. But basically, it was just a very big query. It tokenized all the web pages, it parameterized them, create hash tables, and so they had very, very clear, but it was not artificial intelligence. It was like a database query. And then all of a sudden, ChatGPT came along, changed things completely. So
yeah.
I think and I saw for people that haven't watched, Yilmaz did a session on Monday where you showed was it a power station? Am I remembering that correctly? What was your you had some functions that was working on something? Was it energy or I remember you saying that you were tuning something for neural networks. It was
Uh,
energy consumption.
Energy and exergetic functions. Yeah,
Yeah, yeah.
in mechanical engineering.
Yeah, and so that's a practical application of what you're talking about. Callum says, and Callum obviously is interested in this stuff. Thanks. I'm inputting arrays of audio data to output classifications for marine animals. Wow, that's interesting. I produced an LSTM network. I don't know what that is. That works fairly well using the ReLU activation. Do you know what that one is? Uh, ReLU activation. I shall try sigmoid. So you've got a convert there,
Yeah, yeah,
Yilmaz.
yeah. Of course, I understand, but I mean this. sigmoid function has a similar effect on the both negative and positive side. So when you give a signal, when you give a data, how you know it is very bad or good?
Right.
Okay, but sigmoid function on the left side and the right side is equal effect on the bad and good side. Okay, so my idea is sigmoid function is good, but of course, if your functions, your activation function could be very good now, but in my opinion, I think signal result should be different. And
Yeah. Yeah. And
did you
carry
we put three results in Google video results.
on.
There was a jeep running in the air water flow. And, you know, I'm a mechanical engineer. I also worked on fluid mechanics. I know how hard to calculate those fluid mechanic things on the grid, two-dimensional grid, and three-dimensional grid is much more hard. And now you say the words, and it is giving you result with the jeep running in the mood, you know. So
Yeah.
results are really amazing.
Yeah, I mean, fluid dynamics was always a subject that everybody knew was hard, even if they didn't know anything about it. It's just one of those things where you hear people saying, "Hey, it's more complicated than you think," and like you say, as a mechanical engineer, it's one of the things you have to understand. And so, if you're going to calculate what's happening with a boat that's floating along in where's it going to end up if the rudder breaks or something like that, that's fluid dynamics. But it applies to even weird things like steel mills. Processing molten metal and stuff like that. There's lots of other, uh, you know, physical systems at play, but literally, if you've got liquid of any type, fluid dynamics comes into it. But air is also can be treated like a fluid as well, and it's a weird, it's a
Yeah.
whole different science.
When you analyze, you are doing mesh and having a large scale of grid. So there are nodes. Each nodes are connected with each other. So you are calculating pressure and velocity and so on. So it is something similar to the neural network, you know.
Yeah.
Also in it is a nature actually, not only fluid dynamics. It is also for other mechanical things in materials also, material science also.
I mean, to put it in layman's terms about neural networks, if you think of anything that is a learned skill, so not an innate skill like breathing, which is you don't learn to breathe, you just either can or you're dead. But it's as simple as that. But if there's a learned skill like riding a bike, for a bicycle, or even computer programming, or making something like this from metal, all of those skills require your neurons to have the pathway strengthened, and that's why we practice it. In layman's terms, practicing is really fundamentally strengthening the pathways of those neurons. That's what we believe is how the brain works. I mean, maybe in 100 years someone will say that's not how it works, but right now our fundamental understanding of how the brain works is that it's neuron based, and that strengthening the pathways means that you can learn to speak French or learn to speak English as you have, or learn to computer program,
Yeah.
and the neural networks are really just um, an artificial creation or reproduction of that process, and you do a very good job of explaining it. And the math is hard, but it's not that hard. Even I understood today's, and I'm terrible at maths. But it's interesting stuff. What do you think? I mean, to me, as a layperson who doesn't, who isn't in this field, to me, it looks like we are very close to having something very incredible with AI. Like the singularity is the thing they always talk about, where AI gets to the point where it is actually so good that it is just you can't understand it anymore. It can, grow beyond itself. What do you think the future is going to be with AI? Speaking as someone who works in that industry and understands it, or maybe just as a human being who's kind of about to have AI change your world. I mean, do you think it's a good thing? Do you feel like there's a future for us that's heading in a good future, or is there something that concerns you?
Yeah, of course, it concerns me too. Also,
Yeah,
I also concern when I'm using AI application because data is very important, and in security or correctness of data is very important. Also, it is when you give something data as a input, how it is good, you know, is it good for now, for 10 years? We don't know. So uh, we see very good developments now, but in my presentation, I give you three different singularity terms. One
yeah,
was technological singularity, other was gravitational, and the third one was mathematical singularity.
yeah,
And I think we are, yeah, singularity term is like mathematical side. I believe that side. On the both negative and positive sides, we have technology is growing up, but we will not reach to the singularity point. But there will be good and bad examples, such as in virus applications and good useful applications. Some people are doing hacker tools, some people are doing health tools. So this is a
yeah.
positive and negative versions, or we can say same with the airplanes. Some are civilian airplanes, some are fighter
Yeah,
jets,
yeah.
something.
So good and evil, and it's a tool that you can use for good, or you can use it for bad. And
Yes, it is like a knife. It's like a tool. It depends on how you use it. If you are a
yeah,
doctor, you can save the life. If you are a killer, you can end their life. Yeah. So, but on the other side, there's some danger thing is we don't know what's going on behind the AI. For example, there's a new update. What happened in this new update?
right. Yeah, there's no release notes, is there? There's no like, oh, we added these
They
lines of code.
cannot, they cannot
Change
really.
that.
There are many changes, many parameters we don't understand also. But what
Yeah.
changed? Maybe they changed the activation values ReLU to sigmoid.
Well, this is terrifying.
Uh, yeah, we don't know what changed, but what will happen to the next? And maybe it is connecting with other AIs. Maybe they are developing together with another new AI. We don't know. So
Yeah,
this is the this is the concerning part for me. Digital technology has always something background that we don't know.
of course. Yeah.
Yeah.
Yeah,
So
it's like the internet. You can say the internet has brought the world together, and it has. It means that I can work from home and you can work from home and things like that. But it also means that we learn that there are people out there whose opinions we do not like, and people whose opinions we do like. And it's like going to a crowded restaurant or a party, and you meet some people that are okay and some people that aren't. But the internet, is still a good thing overall. I think so. And I think AI is the same. I always say I'm a optimistic skeptic. I'm
yeah, me too.
optimistic
Me
because you,
too. But I
yeah,
am also concerning. Yeah.
yeah, exactly. That's good. At least I'm not crazy then. Yeah.
As
Well,
as a human, we should be always in positive. We should try to do as much as good things for the humanity.
yeah,
There might be negative things happening, so we should reduce this as much as also. So
yeah,
this will go on like this.
yeah. Well, you are a great guy. I mean, you're a good friend. You and I talk quite often about things. you're one of the smartest people I know, Dr. Yilmaz Yoru. I always call you Yilmaz, but it's Dr. Yilmaz, just so that people know that
Yes.
you're the
Yes.
real deal as well. And I thank you for that session. You did a great job, and thank you for the session on Monday as well. You know, I think you bring some kind of. I mean, Boyan is another guy who's very smart as well. You two, maybe if we put you both in the room, the gravity would just sink together because those brains would just, you know, together. But
I believe everybody is intelligent. I think, but
yeah,
we
yeah.
focus on different areas. So especially programmers and engineers are much more maybe using these kind of mathematical things. So uh, mm, I believe everyone has.
I know you're being very modest, but I
Yeah.
know overall you're actually a really smart guy as well. Anyway, it's not a problem. All right, well, thanks a lot. We're out of time, but Yilmaz, thank you so much for
Thank
taking
you.
part, and we'll see you in another time soon. All right, thanks a lot. Bye bye.
Bye bye. Thank you.
Isn't he great? You know, he is. I'm going to get rid of some captions here and things like that. He's still behind the scenes in the studio, but is done now. Okay, so I really like that stuff. You know, Yilmaz has this way of explaining things. If you go to the Learn C++ site, in fact, I'll put that back up again. There, he has whole sections. He's written thousands and thousands of words on ANN, artificial neural networks. If you follow through, some of the material is quite dense. It's quite hard going. You know, it's academic, some of it. But actually, overall, if you want to know, if you want to really understand what goes on behind the scenes, how artificial neural networks work, that's the place to go. There's good stuff there. While we're at it as well, Yilmaz also has his own website as well, because as he said on Monday, we put the links up, but he's also got a bunch of stuff there as well to do with AI in general. Really smart guy, good C++ guy as well, is one of our MVPs and a few other things as well.